Hello everyone. In this video I want to show you one of our projects which we design a data acquisition system which able to measure and record the EMG signals. So then we actually use that EMG signals and design the algorithm that able to turn on and off any electrical device based of that EMG signal. So let's first test that and see how it works. So here I actually connect the wires to my muscle, which able to measure the electrical activity on my muscle. So as you could see, whenever I contract my muscle, it's actually able to measure the EMG signal. You could see the EMG signals on the LCD, and I actually, whenever I contract my muscle and release, it's able to find the spike that I have on the EMG signals, and the software based off that peak able to turn on and off any electrical device. Here I just put the LED, which is just turn on the LED, but definitely in rehabilitation engineering it could be any motor that people able to actually control any motor with actually muscle contraction. So it could be any type of the device. So here you could see I actually contract my muscle. It's actually detect the peak or threshold in the EMG signals and able to turn on the LED. So right now I'm able to control that. I actually turn that off. So right now another contraction, it's actually turned the LED on. So I actually turn that off. So again, you could actually do that on, off, another contraction, actually on, another contraction, actually off, another contraction, actually on, and you could actually control whenever you want to actually turn on and off that specific device. So let's see how you could actually make that. So we actually use the TIVA C-Series, Texas Instruments TIVA C-Series launchpad, which is the Cortex M4 microcontroller. So here you have the EMG sensor, and this EMG sensor able to record the analog signals and send that to the microcontroller, and the microcontroller actually has specific software which able to detect the peaks and it's know the muscle contraction based off the threshold that you define for that. Then whenever it's detect that threshold, it's actually toggle these LED. So that means whenever you see first spike, it's turned on, in the second actually spike, it's actually turned off. So the whole thing, it's actually the microcontroller connected through the UART to the LCD. The LCD that you see here is the next gen LCD. That's actually a smart touch LCD. So for programming that, you need to actually, it has actually its own software. You design whatever you want to have on that, then save the file inside the small flash driver, and in the back of these LCD there you could actually insert that flash and upload the software inside these LCD. We just use the simple graph for our case, and it's just able to plot the signals that we have. So as you could see here, again with the contraction, I'm able to turn on the LED, here again turn off, and you see the spike of the EMG signals. So the software, actually we have two main tasks in the software. The first, we have some filtering, which is actually filter the EMG signals. The EMG signals actually is very noisy signals and it is tough to work on that. So you need some good actually filters which that able to give you a clean EMG signals. So we actually filter the EMG, then we have another software which actually detect the peak of the spikes on the EMG signals, and based on that turn on the LED that we have here. Okay, so as you could see, anytime you could actually turn on and off the LED, and also on the LCD you are able to see actually what's happened. Okay, so again I fix this. So again, so you see you actually turn it on and also off, and for any on and off you could able to see the signals on these LCD that we have. So to do that for a few times, as you see, it works perfectly, and definitely you could control any electrical device with your muscle contraction. Thank you for watching this video, and I hope you like this video.